Hello everyone, and welcome back. Thank you for tuning in. So, thank you for tuning in, and we are gonna move on to chemical change. Okay. So, I want to give you a proper introduction on chemical change. So, for lesson one, okay, we're going to do an introduction to chemical change. Okay, so I will give you what's important here about. I want to introduce you to the topic first before we do some exercises. So we're going to familiarize ourselves with the important terms about this topic. Okay. So we can't do the whole topic in one lesson, but here we're going to get the ball rolling. Okay. So we're going to introduce a few key concepts and a list of formula that you need to know here. So we're going to start with the number of moles. Okay. So the number of moles, there is three formulae. So there is mass divided by molar mass. And then there is the one where we use volume and then divided by molar volume. And then there is N. So there are three for the number of moles. We use this three. So it depends on the information that you have on the question. And A. And A is Avogadro's number. And then there are two. There is two for C. There is two for concentration C equals to N over V. And C equals to. So if we don't have the number of moles, we can use the mass. Okay. M divided by capital letter M. And so guys, it's very important here to make the distinction between the small letter and the capital letter. Okay. We have a capital letter and we have a small letter. They don't mean the same thing, isn't it? Small letter is the mass, the capital letter is the molar mass. And okay, even the unit of measurement is not the same. Okay. So let's write down the symbols here. Okay. What do they mean? We start with the small letter N, which represents what? Number of moles. And the unit of measurement is MOL. Mole. number of moles. So, and then we have the small letter. M is the mass, and the unit of measurement is grams. Okay. And then we have a capital letter M, which is the molar mass. Molar mass. Okay. Molar mass, N is grams per mole. Grams per so the capital letter here is found where? The capital letter is found on the periodic table. Okay. So the number here is found on the periodic table of elements. Okay. Unless if, so the thing is, sometimes you are required to find this. Okay. Sometimes if they want you to identify the element in the question. So in some of the cases, you have to find it, the capital letter, such that you can find the element that was used in the question. So it's not always given. That's what I'm trying to tell you. The capital letter is not always given, but in most cases, it is given. Sometimes they want you to find the capital letter M so that you can find the element that was used. Okay, you will see questions like that where they require you to find this. Okay, so don't worry, I'll show you. And then the V is the what? It's the volume. So the volume of a substance, and the unit of measurement is cubic decimeters. Okay, and again, what happens here is we should be able to convert. The volumes should be converted, isn't it? Sometimes the volume can be given in cubic centimeters. Okay, the cubic centimeter should be converted to cubic decimeters. How do we do that? We divide by 1,000. So we divide by 1,000 if we want to go from centimeter to cubic decimeter. Okay, so the unit conversion is very important here. We should know how to convert from one unit to the other unit. Okay, so, and then from there, we go to the VM here. VM, what does that mean? This is a constant, okay? So this is a molar gas volume. The molar gas volume, and at STP, and STP, what does that stand for? It's standard temperature and pressure. A standard temperature and pressure. And the molar gas volume at standard temperature and pressure is a constant, okay? It's 22.4 cubic decimeter per mole. So at standard temperature and pressure, the volume is a constant. So of a gas of 1 mole. Okay. So unless otherwise stated, we use 22.4. Sometimes they give you a specific number, but in many cases it's 22.4. If they say it's a standard temperature and pressure, it means that the volume is 22.4 here. Then the next thing is the N, okay? So this one is the number of particles. This one is the number of number of particles. So there's no unit here. It's just a number. So the number of particles could be what? Could be atoms. The particles here could be atoms, molecules, or formula units. Formula units. So this is the number of particles that we're talking about. And then Na, okay. So this is the number below the N here. Okay, so guys, you see, this is the distinction you make here. The distinction between the capital letter N and the small letter n. The small letter n here is the number of moles, isn't it? It's the number of moles. And the capital letter is the number of particles. See, that is the distinction. Do not confuse the two, isn't it? There's the capital letter and there's the small letter. Just like the M, there is the small letter and there's the capital letter. They don't mean the same thing, isn't it? Do not mix up the information there. And then Na is what? This is Avogadro's number. This is Avogadro's number, and it's a constant, okay? It's a constant, and I will give you the definition shortly. So it's a constant is 6.02 multiplied by 10, and then 23. 10 exponent 23. Okay, and then now the only thing left at this point is the C. Okay, the C, which is the concentration. Okay, the C is the concentration. The C, small letter, stands for concentration. This is the concentration. The unit of measurement is mole per cubic decimeter. So it's mole per decimeter cubed. This is the unit of measurement here. And so, guys, you see, some of these things don't have units, isn't it? So if I don't give you the unit of measurement here, it means that that number does not have, that physical quantity does not have a unit of measurement, okay? The volume has, the molar mass has, the mass has, the number of moles we use MOL, okay? Molar gas volume, again, is just a constant. Number of particles, there is no unit. There's no unit of measurement here, okay? It's just the number of particles. They will tell you how many particles you have. So there's no unit of measurement here, okay? Even Avogadro's number is just a number, okay? So it's the number of particles in 1 mole of a substance, okay? So this is, guys, what we're gonna start with, okay? I want us to have a full grasp of these 5 formulae that I gave you here, okay? We are still going to look at other things, but I want us to start here to understand, because it forms the base of everything else, okay? If you understand these 5 formula, then you won't have problems going forward. And then there are a few definitions also that we have to familiarize ourselves at this point. So, because sometimes they will ask you to define. So there are a few definitions that we have to know here. Let us start with mole, okay? What is a mole? So when we're defining a mole here, you must remember that we make reference to carbon. We use carbon here to define a mole. So a mole is, if you look at carbon 12 on the periodic table of elements. So we say that the mole is the amount of substance having the same number of particles. Having the same number of particles as there are in 12 grams of what? Carbon 12. So we make reference to carbon here when we're defining a mole. We use carbon 12 on the periodic table. Okay, so the key word here is the amount of substance. And then having same number of particles as there are in 12 grams carbon 12. Or we can say 12 grams of carbon 12. So always remember that when we're defining a mole, we make reference to carbon 12. It will make things easier. So we make comparison to carbon 12 here. So it is the amount of substance having the same number of particles as there are in 12 grams of carbon 12. So 12 grams of carbon 12. It makes things easier if you just remember that we use carbon to define what a mole is. And then the next thing is the what? Is the molar mass. It's the molar mass. So molar mass, as we've seen previously from here, is the capital letter. It's the capital letter on the first formula here. Okay, and what is the definition? What is the definition? Because we have to know how to define it. So it's the what? It's the mass. The mass of 1 mole of a substance. Of a substance. That's what molar mass is. It's the mass of 1 mole of a substance. And then standard solution. Oh no, let me begin with concentration first. So let us look at concentration. Concentration. So that's the small letter C. That's the small letter C from above here. The last thing here. How do we define it? Number of moles. So this is number of moles of a substance per cubic decimeter. Per cubic decimeter. Cubic decimeter. Or you can say number of moles of a substance in 1 cubic decimeter. Or in 1 liter. Okay, per liter or per cubic decimeter. Because 1 cubic decimeter is the same as 1 liter. So even if you say per liter over here, instead of you saying per cubic decimeter. But if you say per cubic decimeter, because it is easy here because you can remember it from where? From the what? From the unit of measurement. The SI unit for concentration is mole per cubic decimeter. But then when you define, you can also use a liter here. You can say per liter instead of saying per cubic decimeter if it makes things easier for you. Okay? And then we can talk about standard solution. standard solution. Okay, this is a solution of accurately known concentration. A solution of accurately known concentration. That's what a standard solution is. It's a solution of accurately known concentration. And then let's look at here at the last one is oh no, not the last. I'll add another one. So Avogadro's number, okay? Avogadro's number. So that's Na. The capital letter that has an A as a subscript. Okay, so Avogadro's number here is Na, the denominator here. So Avogadro's number is that number here, okay, 6.02, then multiply by 10 to the power of 23. So how do we define Avogadro's number? Because you have to know how to define Avogadro's number as well. This is, so this is the number of particles, the number of particles, the number of particles. So those are, so it could be atoms, molecules, or formula units. Particles or formula units present in one mole. Present in one mole. So that's Avogadro's number, the number of particles present in one mole. So when we mean particles, it could be atoms, molecules, or it could be formula units. And then STP, this just means what? Standard. I just thought I'd add this one. Standard temperature and pressure. Standard temperature and pressure. And pressure. That's what it means. Okay. So yes. So let's leave it here for lesson 1, okay? This is just wanted you to become familiar with the terms and with the formula that we're going to use in this section. So in lesson 2, we're going to do an example of a question, okay? An example of a question, and we're going to use this formula here, okay? So please tune in for lesson 2, okay? So let's leave it here for now. Stay focused, and thank you for tuning in again, and I will see you in lesson 2, okay? So please tune in for lesson 2.